Now that we've learned all of the different ways to solve quadratic equations, I wanted to make a video to go through a summary of what they all are and the order that we should be looking to use them in. So we're going to go through this like a flowchart as a series of questions leading us to different ways of solving. So question number 1 is C equal to 0? If C is equal to 0, then we should be solving by using GCF only. So we shouldn't need to do any fancy methods. It's the absolute simplest kind of quadratic. So as an example, let's say we had something like 2x squared plus 3x is equal to 0. Since C is equal to 0, that means one of our x-intercepts is also the y-intercept, which is at the origin. So we factor this one by taking out x as a GCF, and we're left with 2x plus 3 is equal to 0. That means that our two solutions is to make this part 0, we need x to equal 0. And to make this part 0, we would need x to equal negative 3 halves. So our solutions are negative 3 halves and 0, and that's the absolute simplest one. If C is not equal to 0, then question number 2, is B equal to 0, or are we in vertex form? If either of those is true, then we're going to solve using what I call basic algebra. You could also call this just inverse operations. So solving it like a regular basic equation that we could have solved the first day that we walked into Algebra 1. So an example of each of these, if b is equal to 0, this includes difference of squares as well, but let's say we had something like 2x squared minus 13 equals 0. So we have a and c, but b is equal to 0. So we would solve this by basic solving steps. So we would do just PEMDAS backwards. We'd add 13 to both sides, getting 2x squared is equal to positive 13. We would divide both sides by 2, getting x squared is equal to 13 over 2. And then we would square root both sides to get x is equal to plus or minus the square root of 13 over 2. So that's how we would follow through with that. Or if we had an equation in vertex form, so something like x minus 4 squared minus 12 is equal to 0. Then again, we can solve that using basic algebra steps. Add 12 to both sides. We're left with x minus 4 squared equals 12. Square root both sides. We get x minus 4 is equal to plus or minus. We simplify that to 2 root 3. And then add 4 to both sides. We get x equals 4 plus or minus 2 root 3. So that's our second easiest kind to solve because there's no fancy like algebra techniques. It's just inverse operations and using the reverse order of operations to solve like we've always done. Number 3, our question is, this is actually going to be a combination. So is it factorable? We're going to kind of group together a couple of things here. So factorable includes a couple of things. So we could have factorable as a perfect square trinomial, which is one of our special cases, or a difference of squares, which is our other special case. Or we could have factorable using the area model like we've been working on. So basically, is there a way to factor it into linear factors? 1 second while I come up with one that is factorable. Okay, so something like 2x squared minus x plus 6 equals 0. Also, perfect square trinomial, you know what those look like, the one that has a perfect square at the beginning, and then something like 4x plus 4 equals 0. So we have a perfect square at the beginning and the end, and the middle number is the right one to make that work. So this one, like the kind of thing we've been doing with the area model where we say 6 times 2 is, oh, this needs to be minus 6, doesn't it? minus 6. So we say negative 6 times 2 is negative 12. And then my bigger number needs to be a negative, and my smaller number needs to have the other sign. So we have a plus factor and a minus factor. So we have 1, negative 12, or 2, negative 6, or 3, negative 4. And we find that 3, negative 4 is the correct factor pair to create negative 1x in the middle. And then we use our area model, and we put 2x squared up here. We put the two factors we found in our factor list in these two boxes, 3x minus 4x, and then the negative 6 in the last box. And then we look for greatest common factors. So on the top row, my GCF is x. This needs to be 2x. Negative 2 goes here. 3 goes here. So my factored version, 2x plus 3 times x minus 2 is equal to 0. And then I get my solutions as whatever makes each factor pair 0, just like in the first case. So we get negative 3/2 and positive 2. So x equals negative 3/2 and positive 2. And that's case number 3, is where it's factorable. Now, if we made our factor list, this one here, and we don't find the correct middle term. So say my middle term here had been a negative 2x. In fact, we can just go ahead and modify. That would make it GCF. Anyways, number 4, if it's not factorable, the next question we ask is A equal to 1 and is B even? If both of those are true, then our next method of choice is completing the square. So that's the one that we've learned pretty recently, where we're going to kind of force a standard form equation back into vertex form, then allowing us to solve like we did in number 2 using inverse operations. So basically, it's a process of creating this out of a standard form equation so that we can then solve it using those very simple steps. So completing the square, if a is 1 and b is even, so something like x squared minus 4x, say, I don't know, minus 21. 21. Actually, that one will work. Let's do 22. Yeah, that definitely won't work. Okay, so that one is not factorable. If I made a factor list of negative 22, it would be a short list. I have 1 negative 22 and 2 negative 11. Neither of those gives me the correct middle term of negative 4. So I'm going to use completing the square. So we've done this process, but I'll go through it really quickly as a review. So we do x squared minus 4x plus something that's going to create a perfect square equals 22. We move this number over here, plus that thing. The perfect square I'm creating is always going to have half of this b term. So I'm going to do x minus 2 squared. And then the magic number I need to complete that square is negative 2 squared, which is positive 4. So I add that to both sides. And then, just like in step 2 above, we use basic algebra to finish solving this. So I square root both sides. That gives me x minus 2 equals plus or minus the square root of 26. Square root of 26 can't be simplified because it is 2 times 13. There's no pairs of factors in the list. So we add 2 to both sides, and we get x equals 2 plus or minus the square root of 26. As a reminder, using this method, we may end up with a case where there's a negative inside of the radical. So if we have that, then whenever we try to square root a negative number, then anytime we do that, we stop the problem and we write no real solutions. That can only happen in completing the square or quadratic formula. You'll never run into that result in options 1, 2, or 3 because none of those end up with radical answers. These 3 all end up with rational solutions, rational roots or solutions. Whereas the number 4 and 5 can end up with irrational solutions that include radicals. Okay, then the last resort that we learned most recently, if we can't do any of those others 1 through 4, then we use the quadratic formula. So no question here, this is just the last thing we have available. And in quadratic formula, we identify a, b, and c from the standard form. We plug it into negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this one I basically break down as a 3-step process. So within the quadratic formula, number 1 is to substitute all of the values for a, b, and c. Number 2 is to simplify the radical. So whatever ended up in this b squared minus 4ac, we call that the discriminant, by the way. That's more of an algebra 2 term, but this b squared minus 4ac is called the discriminant. If that ends up being simplifiable, we want to simplify that part by taking out anything that's a perfect square. And in number 3, then, we simplify the fraction part. And with simplifying the fraction, keep in mind that we have 3 terms, and we have to divide them all by the same number. So let's say we ended up with something like negative 2 plus or minus square root of 7 over 4. You may be tempted to try to simplify this negative 2 and this 4 because they're both even, but you're not allowed to do that because there's 3 terms here, and we have to divide the same number out of all of them. If I had negative 2 plus or minus 6 root 7 over 4, this would be fine. I could simplify this, so I have an even number, an even number, and an even number. Or for the second one, an even coefficient. So if I divide all of those by 2, I would get negative 1 plus or minus 3 root 7 divided by 2. So I divide all 3 terms by 2 to reduce that fraction. It's very similar to the idea if I had negative 2 plus 6x divided by 4, it would be the same idea. So the square root of 7 here doesn't change, just like here, the x wouldn't change. I would get negative 1 plus 3x over 2. So yeah, those are our 5 methods that we have to solve with and the thought process that we want to follow. And really, like, this should take seconds as you're approaching a problem. You shouldn't be spending the 12 minutes we've spent in this video. You should be thinking, I don't see that b or c is 0 and it's not in vertex form. So we've already moved on to number 3. We do a quick check to see if it's factorable using this list of factors. If it's not, or we check if it's a special case. If it's not factorable, then we do a really quick check. Is a equal to 1? Is b even? If so, complete the square. If not, we move on to quadratic formula. So when you look at a problem, the really quick evaluation of which method to use should take you 30 seconds at most. It should not take you a long time. And the more you practice it and kind of follow through this thought process, thinking about these questions, you'll get faster and faster at it.